The Ashmolean is University of Oxford's Museum of Art and Archaeology and the world's first public museum. It opened in 1683 and represents most of the world's civilizations, covering almost 500,000 years of history. It is visited by more than 850,000 people a year. The facade of the present building dates from 1845 and was designed by Charles Cockerell. And in 2009, a major redevelopment project saw the creation of 39 new galleries by Rick Mather Architects. In 2014/15, we replaced roughly 2,000 gallery lights in the museum to save energy. This is a swap from halogen bulbs to LED equivalents and has saved us roughly 236 tonnes of carbon every year since then. The next phase of this project looked at our showcases. Each showcase has a fibre optic system which operates through what we call a light generator. This is stored either above the case or to one side. The benefit of this system is it protects a delicate microclimate within the showcase. These generators use 100-watt halogen bulbs, and our challenge with this project was to find an energy efficient LED equivalent source that could be used with a high enough quality, output and longevity so that we could replace the halogen bulbs throughout the museum. With roughly 500 showcases to do, this was quite a challenge, and we looked at many different equivalents until we finally settled on the solution that we find today.
Absolute Action have been specialising in fibre optic technology for the past 30 years plus. One of the biggest challenges we've had to face recently is the transition from high energy halogen lighting to low energy LED lighting. Halogen lighting has the quality that the very best museums in the world wish to see for lighting their artefacts and exhibits. So we needed to match that as close as we could. And that quest led us to Soraa.
LED has evolved greatly over the past few years, ever since our co-founder Shuji Nakamura invented the first blue LED back in 1993. Until recently, most developments have been really focused on the lumen outputs, making sure LEDs are brighter. However, there's been a real trade-off against the quality of light. Traditional LED lighting, they start with a blue LED chip and then they add a red and a green phosphor to give you the RGB mix. However, at Soraa we do this slightly differently. We use a violet chip and we use a 3-mix, what we call triphosphor, gives you your red, green, blue mix. The mix of our phosphors with our GAN-on-GAN technology enables us to give you full spectrum, and we have the ability to give you white rendering. And this is something that's an industry first within LED lighting.
We explored ways of re-terminating any fibres that have been damaged on site, and then devised components and a system so that we could train museum staff so that they could undertake this restoration work themselves. The Soraa lamps will now last for more than 10 years, but the fibre will last in perpetuity.
It's been fantastic to work with Absolute Action and the University of Oxford on such a prestigious project. The Ashmolean Museum is a UK institution, and for Soraa to light the display cabinets has been an absolute honour.